Okay, we're here at the bottom of page 3 for section 4.5. And we're now in the practice plus section, which we know, of course, that means that we are going to be combining more than one type of skill into one problem. So in this case, we're going to be doing some translation as we answer the question. So the question here is to write the equation in slope-intercept form that satisfies the conditions. So we want to get all the way to y equals mx plus b, because that shows our slope m and our y-intercept b. Okay, and the conditions are given. So they're going to give us some information. We're going to take that information and get ourselves to y equals mx plus b, which means that we're going to want slope, and we're going to want our b value, which means our y-intercept, or the coordinate of the y-intercept. But sometimes they won't give us directly the y-intercept. We may have to use the route of falling back on the plan of using the point-slope form of the equation to roundabout get to the slope-intercept, okay? Remember, that shouldn't surprise us. We're in section 4.5 that uses, that is talking about point-slope forms. So we may have to use our fallback plan. If they don't give us slope and the y-intercept directly, we may have to use the fallback plan of point-slope form to get there. But let's see what they give us, okay? And it's going to be a practice plus, so we're going to have to translate some of the information that they're giving us here. The line passes through 5, negative 9, and is perpendicular to the line whose equation is x plus 7y equals 12. So deep breath. Let's read that again. The line passes through 5, negative 9, and it's perpendicular to the line whose equation is x plus 7y equals 12. So they're telling us two things. They're telling us about a point on the line, and they're telling us about the slope. Okay, anytime you see the words perpendicular or parallel, they're telling you a clue about the slope of the line. Okay, so what we're being given is any old point, so a point on the line, and slope, or at least a clue about it. Okay, so we're gonna have the information to be able to fall back and use our point-slope form. We just aren't quite there yet. We have the point. We have the point 5, negative 9. So there's our x1, y1 that we would need for y minus y1 is equal to x times x minus x1. Okay. From there, we'll rearrange it by solving for y to get to the y equals mx plus b. Okay. So we'll rearrange to get there. But for now, we have the point xy, and we have a clue about the slope. The clue is that it's perpendicular. This little upside down capital T means perpendicular to x plus 7y equals 12. Okay, so this is why I picked this one, so that we could work this through together. Okay. If they give us the equation line, by the way, this equation is in standard form. It's in its formal version, what I like to call that. Formal, friend, fallback. Okay. It's in formal version, which means that as we look at it, there's no m value here. There's nothing that gives us a clue about m. Okay, so how can we find slope? Because we're going to have to do two things. We're going to have to find slope here, and then perpendicular to slope means that we're going to want the negative inverse of the slope for this line. Okay, so perpendicular means we have to find the slope for this line and then find the negative inverse for that to be the slope of the line we want. So this is quite an intricate problem. There's several steps here. You really have to understand what you're being given and understand what you need to do. So how can we find slope? Well, this is something that if we can rearrange a formula to y equals mx plus b, we can see the slope. It'll be the number right in front of the x. So solve for y. and you'll be able to see slope in front of the x. Okay, so we're going to take our our x plus 7y is equal to 12, and we're going to solve for y. So we're going to subtract x, and we get 7y is equal to 12 minus x, or you could rewrite that as negative x plus 12 if that's more comfortable for you. Divide everything by 7, and you get y is equal to, and I'm going to use this version right here, negative 1/7 x plus 12 over 7. Don't be too concerned that you've got a bunch of weird numbers here, because the only thing we really care about is that number in front of the x. Now what I did there was I divided every piece by 7, so it was 12 over 7 minus x over 7, or 1/7 x, or I just rearranged it so the x piece would be first. This is 1x, and negative 1x over 7 becomes the negative 1/7 out in front of the x. Okay, so however you want to think about that, but the coefficient in front is going to be negative 1 over 7. So that's our slope. Our slope is negative 1 over 7, but that's the slope of this line. That slope is negative 1/7. We want perpendicular to that line, which means we want perpendicular would be the negative inverse, which means you flip it, which would become 7 over 1, and you change the sign. So in this case it was negative, now it's positive. So we want the negative inverse, that's positive 7 over 1, or just positive 7. So the slope that we want for our line is going to be positive 7. Okay? So the slope was a little bit of a journey. We had to take the line they gave us, find its slope by solving for y, take that number in front of the x, and because we were told it was perpendicular, we had to flip it and do the opposite sign, the negative inverse of it. So it'd be positive 7 over 1. Now we have, let's keep track of what our goal is. Our goal is to come up with slope-intercept form. What we now have is any old point on the line and slope, which means we can use our fallback plan of y minus y1 equals m times x minus x1. So here's our slope, here's our x1, here's our y1. So y minus y1 is going to be y minus the negative 9, minus whatever you see here, subtracting the coordinate, so y minus negative 9, equals our slope of 7 times x minus whatever the x is, so in this case it's x minus the positive 5. So there's our point slope form, but our goal is to get to the slope intercept, so we do that by solving for y. We're going to get y all by itself. To do that, we need to distribute the 7, so you get y plus 9, y minus a negative 9 is y plus 9, equals 7 times x minus 35. 7 times minus 5 is minus 35. Subtract 9 from both spots, and you end up with, from both sides I should say, y is equal to 7x minus 44. That is the slope-intercept version, and we've got a lot going on, so I will go ahead and highlight that answer. Y equals 7x minus 44 is the slope-intercept form. These are intense problems, and we have at least one of them like this on the test, if not two, where there's some clues in a description format where you're going to have to put together what they're giving you and then eventually plug it in. So in this case it was kind of a journey to get to slope. Let's do another one together. Let's look at number 36. The line passes through 2, 6 and has the same y-intercept as the line whose equation is x minus 3y equals 18. So a little bit different pieces of information here. Again, let's keep our goal in mind. Our goal is to come up with y equals mx plus b, which means that what we need is our slope value for m, and we need the y-intercept value for b, the point 0b. So this one says the line passes through 2, 6 and has the same y-intercept as the line whose equation is x minus 3y equals 18. So this time they're giving us a clue. They're giving a clue about the y-intercept, but they don't give us anything about slope. So that means if we don't have slope given to us, we'll need 2 points to plug into slope formula. There's two things we're trying to solve here. What is the slope? What's the y-intercept? They gave us a clue. It's the same y-intercept as this line. And then they tell us one of the points. They say the line passes through 2, 6. So if we need 2 points to find slope, we'll use the given point of 2, 6 and the y-intercept once we find it. It'll be 0, some number. Okay? So that means we have to start with finding out the y-intercept. We can't come up with slope yet because we only have 1 point on the line, and we need 2 points to come up with slope. But we know it's the same y-intercept as the line. Now again, this line has been given. It's the same y-intercept as x minus 3y equals 18. Again, this is in the formal version, standard form of the equation. Standard or formal version, which means that we can't see the y-intercept. Okay, so to see the y-intercept, to see what that is, we want it in y equals mx plus b form because it would be right there in our b value. So how do we do that? We're going to solve for y. So we're going to take x minus 3y equals 18. We're going to subtract the x from both sides, and I get negative 3y is equal to negative x plus 18. I went ahead and put the x piece up front because I know I want the mx plus b form. It doesn't really matter, but since we're used to seeing it that way. Divide everything by negative 3. I'm going to run out of room here. Sorry about that. And I get y equals negative 1 over negative 3 is a positive 1/3 x plus 18 over negative 3 is negative 6. In this case, we're not interested in the slope. We're interested in this y-intercept because the clue was it's the same y-intercept as this line. So we rearranged this line into y equals mx plus b so we could see the y-intercept. Once we see it, we now know what our b value is. We now know that the y-intercept is 0, negative 6. Our b value is negative 6. We're part way to our answer here. We want y equals mx plus b. We now know our b value is negative 6. So it's going to be x, something times x minus 6. Okay, so we know half the answer here. We know the y-intercept. But we all still need the slope, and we wrote out for ourselves that we needed 2 points to plug into the slope formula. We were given 2, 6, and we'll use the y-intercept once we get there. Now that we found it of negative 6, we can use those 2 points to find slope. Okay, so our slope, I'll use a different color here. Our slope is equal to y2 minus y1 over x2 minus x1. So here's our points. I'll call them x1, y1. x2, y2. So I'm going to take negative 6 minus 6, negative y2 minus y1, so it's whatever y2 is, negative 6, minus whatever y1 is, 6. On the bottom, x2 minus x1, 0 minus 2. And what I get is negative 12 over negative 2, which is a positive 6. So that's our m value. And so our final version of the equation is y of the slope-intercept form of the line that passes through 2, 6 and has the same y-intercept as this equation, x minus 3y equals 18, is y equals 6x minus 6. There's our slope, there's our y-intercept, y equals 6x minus 6. Take a moment to talk these through either just to yourself or hopefully to someone else so you can kind of talk through. These are really involved problems, multi-step. You have to keep track of where you're going and how you're going to get there. For me, giving myself some steps along the side, some reminder points will be helpful. Okay, I'll talk through this one more time for you. It passes through a point and has the same y-intercept as another line. So we had to find what that y-intercept was because we wanted slope and intercept to get to y equals mx plus b. That was our goal. Our goal was slope-intercept form. So we wanted slope, we wanted intercept. They didn't give us either, but they gave us a clue to y-intercept. So we were able to solve this second line for y so we could see the y-intercept of negative 6. Then with the first point they gave us, we now had 2 points, and from 2 points you can always find slope. And then we had what we wanted, our slope and our y-intercept. Okay, we'll see you on page 4. Good job.